Good day, everyone. Our lesson for today is to illustrate the permutations of objects. Once again, I am Gerardo T. Biduya, the teacher of Ordinata City National High School. So, if n is a positive integer, then n factorial denoted by n exclamation point is the product of the positive integers n and all positive integers less than n. Thus, n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 and so on multiplied by 1. By definition, 0 factorial is equal to 1. Example number 1. If n is equal to 4, then n factorial is equal to 4 factorial is equal to 4 multiplied by the quantity 4 minus 1 multiplied by the quantity 4 minus 2 multiplied by the quantity 4 minus 3 is equal to 4 times 3 times 2 times 1, then it is equal to 24. For 2 examples, 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 5,040. Number 3 example, 3 factorial is equal to 3 times 2 times 1 is equal to 6. Number 4, 2 factorial is equal to 2 times 1 is equal to 2. Number 5 factorial times 0 factorial is equal to 5 times 4 times 3 times 2 times 1 times 1 is equal to 120. It can be written as in permutation. But first, let us define what is a permutation. A permutation refers to an arrangement of objects in a definite order or the ordered of arrangement of distinguishable objects without allowing repetition among the objects. So we have here your equation. The permutation of n objects taken r at a time is equal to n factorial divided by the quantity n minus r factorial, where n is the number of objects and r is the number of objects taken r at a time. It can be written also as n multiplied by p times n. Then can be written also as the permutation of n taken n at a time is equal to n factorial, where the permutation of n objects taken n at a time, where n is equal to number of objects and n is equal to the number of objects taken at a time. Example, if n is equal to 4 and n the number of objects taken at a time, then the permutation of n object taken n at a time is equal to n factorial. So by substituting the value of n, we have the permutation of 4 taken 4 at a time is equal to 4 factorial. Then we have now 4 times 3 times 2 times 1 is equal to. Okay, we can use another equation, which is the permutation of n object taken r at a time is equal to n factorial divided by the quantity n minus r is factorial. So by substituting the value of n, which is equal to 4, then we have 4 factorial divided by the quantity 4 minus 4 factorial is equal to 4 factorial divided by 0 factorial. And we have 4 factorial is equal to 4 times 3 times 2 times 1. divided by 1 is equal to 24. Another example, if n is equal to 5 and r is equal to 3, what is the permutation of the object? Using your equation, permutation of n object taken r at a time is equal to n factorial divided by the quantity n minus r factorial. So, substituting the value of n and r, we have 5 factorial divided by the quantity 5 minus 3 factorial is equal to 5 factorial divided by 2 factorial, and 5 factorial is equal to 5 times 4 times 3 times 2 times 1 divided by 2 times 1 is equal to 60. Okay, if the objects are repeated or distinguishable, we can use the equation P is equal to n factorial divided by O sub 1 factorials, O sub 2 factorial, O sub 3 factorial, and so on, where n is the total number of objects and where O sub n is the number of operands of n object. Activity 1. Write permutation if the activity illustrates permutation, and write not permutation if not. Letter A. Arranging 4 students in a line. The activity illustrates permutation because the arrangement of objects are important. For example, the arrangement of line of Mario, Glenn, Peter, and Julius is different from the arrangement of Peter, Glenn, Mario, and Julius. Letter B. Selecting 5 people from 10 people to form a students' affairs committee. The activity does not illustrate a presentation because committee members, with the exemption of the leader, are not ranked among themselves. A committee, for example, composed of June, Mario, Maria, Pete, and John, is the same as a committee of Mario, Pete, June, John, and Maria. Letter C. Assigning seats to guests at dinner. The activity illustrates permutation because the arrangement of objects are important. Letter D. 6 people posing for pictures. The activity illustrates permutation. The arrangement of objects are important. For example, posing for pictures of Jane, June, Mario, Peter, Jake, and Sam is not the same posing pictures of June, Jake, Sam, Mario, Peter, and Jane. Activity 2. Show the different ways. Jane has 4 different colors of pants, namely brown, white, gray, and violet. She also has 3 different colors of shirts, namely yellow, red, and pink. Question letter A. What are the different pairs of dress that she can wear? Letter B. How many different pairs of dress that can she wear? Letter C. Is there a shorter way of determining the total number of pairs of dress that Jane can wear? Show if there is any. In letter A questions, okay, in question letter A will have to use a tree diagram. We will pair the different colors of pants, namely brown, white, gray, and violet, and three different colors of shirts, namely yellow, red, and pink. So the outcome here is brown, yellow, brown, red, brown, pink, white, yellow, white, red, white, pink, gray, yellow, gray, red, gray, pink, violet, yellow, violet, red, violet, pink. So these are the different pairs of dress that she can wear. Letter B, how many different pairs of dress that she can wear? So we have 12 different ways. Letter C, is there any shorter way? Yes, we have to multiply only the number of different colors of pants and the number of different colors of shirts, or we are using your fundamental principles of counting, which is 4 times 3 is equal to 12 ways. Next, 5 pairs of students wants to have their pictures taken. In how many ways can they arrange themselves in a row if, letter A, they may stand anywhere, and letter B, pairs of students must stay together. In letter A, the question is the may stands anywhere, so therefore we have n, the number of n object is equal to 10, and r taken r at a time is equal to 10. So we have the equation, the permutation of n object taken n and r at a time is equal to n factorial. So by substituting the value of n, where n is equal to 10, so we have 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 3,628,800 ways. Okay, if we arrange 5 pairs of students who have their pictures taken, the first arrangement of the 5 pairs of students will be A, B, C, D, E, F, G, H, and I, J. In the second arrangement, they can be rearranged by exchanging their possession. So if we have AB, we have BA, CD, we have DC, and so on. On the third arrangement, they can be rearranged that the second will be the first, the third will be the second, and so on. On the fourth arrangement, the third will be the first, the fourth will be the second, and so on. On the fifth arrangement, the fourth will be the first, the fifth will be the second, and so on. So we have now here the permutation of two objects taken two at a time multiplied by permutation of two objects taken two at a time multiplied by the permutation of two objects taken two at a time multiplied by the permutation of two objects taken two at a time multiplied by the permutation of two objects taken two at a time and multiplied by the permutation of 5 objects taken 5 at a time. So we have now 2 factorial multiplied by 2 factorial multiplied by 2 factorial multiplied by 2 factorial multiplied by 2 factorial multiplied with the quantity of 5 times 4 times 3 times 2 times 1. Then we have 2 times 2 times 2 times 2 times 2 times 120 is equal to 3,840. Next, from the digits 3, 4, 5, 6, 7, 8, and 9, how many arrangements can be formed using 3 digits and 4 digits? So, letter A, questions, we have n is equal to 7, r is equal to 3. So here we are using your equation, the permutation of n taken r at a time is equal to n factorial divided by n minus r factorial. So we have now 7 factorial divided by 7 minus 3 factorial. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1 is equal to 210. Next, if n is equal to 7 and r is equal to 4. So we have again your equation. Then by substitution, we have 7 factorial divided by 7 minus 4 factorial. So we have 7 factorial divided by 3 factorial. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 is 8. Okay, activity 3. Is it distinguishable? Find the number of distinguishable permutation of the word substitution. So we have the number of objects. We have 12 and there are 2 s, so is equal to 2 u. There are 2 also. I, we have 2i, and t, we have 3. So we are using permutation of n object is equal to n factorial over o sub 1 factorial, o sub 2 factorial, o sub 3 factorial, and so on. So is equal to 12 factorial divided by 2 factorial times 2 factorial times 2 factorial times 3 factorial. So we have now 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 2 times 1 times 2 times 1 times 3 times 2 times 1. So we have now 9,979,200. That ends my topic. Thank you and stay tuned for the next virtual instruction.